Okay. So thanks, Wong, to share his thought about the ELT and ETL thing. Okay, so in the next section, we are excited to have Issac from OpenHive. We'll be talking about the data collaboration with federated learning. So federated learning is also having some increasing awareness in Hong Kong recently, and then hopefully Issac can help to explain a bit
Yep.
for the topic today. Okay, so Issac, can you hear me well? It's okay?
Yes, loud and clear. Thanks for introduction
Okay.
as well.
Yep. Okay. So
So
I pass the stage to you. Thank you.
it's on my turn now. So happy to see you guys right here despite the typhoon. So I'm Isaac from OpenHive Technology. We are a company from WeBank, a brand from WeBank, promoting technology including privacy enhancing computation technologies, blockchains, and AI as well. Today, I would like to walk you through several topics one by one. That is federated learning as a necessity for this new AI era, and then telling a bit about how federated learning itself is related to a broader scope of technology, the PEC, and also introducing some very compelling use case, cross-industry use case for FL. And then finally, I'll be showing you the OpenHive federated learning enterprise solutions with an overview. So to begin with, I will be saying that we have been hearing a lot from the media, especially from those AI giants or leading companies, that there has been advancement in algorithm and then resulting in significant improvement of the adoption of AI elsewhere, anywhere. So it sounds like it is very promising, and AI adoption is proliferating. But as a second thought, is it really true? So when I'm talking to enterprise, so what they are really facing is that despite they are having the access or in the custody of many huge volume of data, so they are facing some foundational problems from the perspective of AI, like data governance and data quality that has been mentioned by many speakers. But most important of all is they are seeing the difficulty is they do not have the relevant data for the use of their some particular use cases for the enterprise. So they are aware that those valuable data is not available within the custody of their own company, but in others' companies. So there is a very strong motivation for either practitioners or either from a business angle that there is data collaborations in a legitimate way between different parties. However, despite that, we have a strong motivation to collaborate, but there are many valid concerns for such collaboration. For example, from the perspective of regulation and compliance, we all know that like medical clinical trial data cannot be shared. And then we are also seeing rising concerns or demands of control from the public or the society over data privacy and security. For example, when we are looking at the response from the public or people towards incidents like Cambridge Analytics, and also the response from enterprise or company towards those regulatory recently imposed like GDPR. So indeed, there are many impacts and concerns over data privacy and those regulatory. And furthermore, data privacy itself is is a topic being looked into in a very stringent way from those regulatory bodies. For example, you can see during 2019, Facebook has been heavily fined for the misuse of data related to the Cambridge Analytics incidents, and also for the data leakage during the end of 2019. So there are huge impact to those enterprises. And then in Europe, you can see that there are GDPR try to govern the usage of AI and also the explainability of AI and also the data privacy, etc., etc. And not only Europe, and you can see that in even that is US, there are concerns on how data is being utilized, being transferred or sold, and there are CCPA to have been passed and exercised to control over these areas. And back to China, we have those cybersecurity law early since 2017, and also PIPL as well. That is some regulatory requirement that is very alike GDPR. So the condition and also control over data and also data privacy is getting tougher and tougher. But despite that, there are more frictions on those using of data and also data privacy. But it indeed has the ground to have such kind of protections or controls, because when those data is not being protected properly or using the proper technologies or techniques to protect, data privacy can be easily exposed, or that can be easily that is contaminated or that is compromised. For example, when we are looking in the Netflix anonymized dataset cases, some clever data scientists, they can make use of those auxiliary data to guess back what individual exactly who is being participate in the data set, despite that all of the PII has been already removed from the data set. So it sounds like there are many ways, or there are many risks of data privacy within the internet, or when we are doing data collaborations. And then another angles or consideration that is dragging the progress of data collaboration is the lack of trust between different parties. It is well known that there are many vulnerabilities in internet, especially regarding machine learning. There may be that kind of data theft, trying to steal the raw data or try to extract valuable information from the model weighting and making inference on the data set, trying to guess back what is the data values from the data being provisioned from those data that is not belonging to the owners. And also, for example, there are some kind of malicious practice to try to change the performance of those model metadata of those model or machine learning tools, and then try to change the prediction qualities as well. And also there may be attacks on those availability of such service. So in a nutshell, there are many vulnerabilities and also many risks if data collaboration is not being done in a properly manner. Luckily, with the advance of the technology, we have federated learning come into place. Federated learning, in short, it is a distributed machine learning network that can enable data collaborations or model training while the data is residing at the source. There's no need to centralize those data, and then at the same time, those data privacy can be preserved with the deployment of advanced encryption technologies like homomorphic encryptions and also PSI as well. So this federated learning has given us a new way to approach the challenges and also the opportunities of data collaborations. And as a matter of fact, PEC as a broader scope of technologies, having federated learning as a key members within this technology scope, we have been seeing the adoption has been very good and very common, even within the space of heavily regulated industry, in the FSI and also in application area like AML. So in this coming sessions, I will be talking a little bit how federated learning is related to the broader scope of technology, the PEC. From Gartner, we learned that these technologies will be the strategic technology trends for 2022. And then what PEC bring into value, or the unique value proposition, is that they give the protections while the data is in use. That is, when the data is being analyzed, so the data privacy and also data protection can be guaranteed. And there are no need for the centralizing of data for the computation of data or building up of models. And there are many technologies within this umbrella. So some of them is more prevailing. For example, like we have been hearing a lot about homomorphic encryptions recently, and also secure multi-party computations, trusted execution environments, and federated learning as well. So each of these components can serve certain use case alone, but most of the time they are using or blended together to achieve a better performance. For example, from the perspective of privacy AI or privacy machine learning, we have been seeing the evolutions of these applications. For example, in the first generation, we are seeing the most prominent technology being used or researched has been the SMPC. And then eventually we have the trusted execution environment. And most recently, we have the sophisticated implementation of privacy machine learning with federated learning. So it has been branded different types of technologies like SMPC, homomorphic encryption altogether to conquer those kinds of challenges related to law compliance, hardware dependency, or that is performance, and also the necessity of putting data together or not. And federated learning itself, I will be seeing it as a tool or a mechanism trying to strike a balance between concerns like or consideration like data protection, privacy, and performance or model explainability as well. So that we are trying to strike a balance between this consideration and give a practical conditions so that we can come up with reasonable data collaboration performance. And we have, by large, two different types of federated learning categories, like horizontal federated learning and vertical federated learning. And in any cases, during federated learning, there will be no exchange of PII and also the raw data itself, but just those kinds of encrypted partial gradients or intermediate modeling results. And also from those paper issued by PCBT, it is also being mentioned that for federated learning, it will be recommended as a means or tools to avoid unnecessary sharing of data during data collaborations. Then I'll be trying to show you different versatile use case across different industries for federated learning and their adoptions. For example, in finance, FSI, we have those underwriting use cases by making use of federated learning, and also in the area of anti-money laundering as well, trying to make use of federated learning to build up some more accurate models. And for example, in insurance space, for customer pricing, we do have this application of federated learning as well. And particularly in marketing in general, federated learning can improve the efficacy of precision marketing as well. And even in the property business, we have been seeing use cases by deploying federated learning so that those kind of visitors or potential buyers of those properties can be more accurately targeted. And that is a case that has been landed last year with the participation of 3 major banks in Hong Kong and Science Park in the middle to support the infrastructure of federated learning. and also the participation of TransUnion to jointly together to validate and ascertain how FL, Federated Learning, can be helping in terms of securities and then preserving the data privacy, and while that is having a very good performance in terms of model predictions. And then having been talking about the motivations of Federated Learning, those challenges, and also some terminologies of Federated Learning. So we are talking more about how we can deploy such use cases from the perspective or from an angle of enterprise. So we need to have a enterprise-grade Federated Learning solutions. So with that, I'm trying to introduce you OpenHive Federated Learning solutions, which can fulfill the most prevailing or prominent demand for enterprise for data collaborations. So OpenHive Federated Learning solution itself is an end-to-end Federated Learning solution. It takes care not just only from the very first beginning, data ingestion, and also the model building, and also for the model serving as well. And then no matter those data collaboration is simple or small scale, starting from like internal collaboration among business units for a particular company, to some external data collaboration between different enterprise, to some scale up network type collaborations across different industry. So the OpenHive Federated Learning solution is able to take care for different scale of this type of collaborations. Having said that, the deployment is very simple. Enterprise need to install at most 1 to 2 software instances, like the computation nodes, or possibly the data market operator node, to make the data collaboration happens. And as an enterprise-grade Federated Learning solutions, we will be seeing that there will be different types of demand and concern. For example, we are expecting a tools that can take care of the end-to-end process of the Federated Learning, not just crunching the data or coming up of a machine learning model that is having a high performance in terms of some technical measurements. So we need to take care of those peripheral process like onboarding, data provisioning, or data subscription approval, or role-based authentication as well. For example, from the interface, you can see that we do have those visualizations to show what is the structures or organization of such Federated Learning network, telling how much sites is being participated, how many data sets are being available. And then every technical details, for example, what is the joining site from, what is the participating site, where is it coming from, is it a legitimate site? We do have this kind of information being shown in different interface. And then besides, there are also concerns about the architecture. Is it secure enough so that even the data is never moving out of the premises of the enterprise, and then it can also facilitate a good performance of machine learning, etc., etc. So we can see that there are features and also utilities. For example, we have the data provider. They can raise the request to the market operators so that they can request for the listing of the utilization of their data, and whether there are any sample to be shown during the listing of data, and then that can be approved or not by the data market operators. And the data market operators also have the interface to review those requests, and then to access whether there are any problem on the request. And then once those requests are approved, data is utilization is being approved, then those potential data requester can request the usage of those data from the markets, and then sending through those requests to the market operators to see if it is a proper request. And furthermore, for any data collaboration, we are expecting everything's are traceable. For example, the what data is being used, when is it being used, how many times it's being used, and what models are being built by what party. So we do have different types of interface to keep track of this detailed information, so that there are complete transparency for any data collaboration being conducted within the platform or the solutions. And then there are concerns on also that is demand for the protections of the IP of the data, and also the IP of the algo assets as well. So there are careful design within the solution, so that, for example, when analysis is being done, those columns characteristics can be analyzed, but still those genuine names of those explanatory variables, columns names, will not be disclosed to the data requester. It will be just being presented as a anonymized way, so that the analysis can be conducted as usual, but the IP or the sensitivity of data is being protected. And for example, when model is built, there is the concern on whether the column names are being disclosed to the counterparty. So there are some design that can protect such concerns, but while allowing the building up of a decent model. And also model has been designed such that which model variables is participated is being disclosed to the proper party. So if that kind of information is belong to not the data requester but the data provider, then it will not be displayed in the interface, and etc. etc. So all the IPs of regarding data and algorithm can be protected within our solutions. And then furthermore, when we are talking about this is a tool used by data scientists, we are expecting a tool that can be easily integrated and easy learning curve for such tools. So we are having the feature so that the solution can be deployed on the Jupyter Notebook as well, so that those pervading machine learning pipeline can be reused and then easily incorporate in those pipeline that is prevailing in the enterprise. So, and the learning curve will be smoothened, and there is no need to start from scratch to pick up this usage for this usage of these tools. And finally, and most importantly, the protection is guaranteed by homomorphic encryption and other mixed type of privacy-enhancing computation, so that those adversarial attacks can be protected, and then the performance of machine learning is also guaranteed as well. And then this is the presentation that I would like to bring forth to you guys, and almost what I would like to share with you today. And happy to talk a little bit more on this one. And Patrick, so I will be stopping a little bit right now.
It's okay. So the time is almost up, but I know that because I think generally talking about the federated learning, people is thinking, okay, how do I set up the test environment, etc. So I saw that you have an operator environment. So is that allow the people don't need to set up their own environment, but actually can engage you guys and then find the operator for more? Just a short quick question here.
Oh, actually, it is not how it is being deployed. So we are just providing the software instances. So for those who want to adopt this solution, they need to install these software pieces into their own infrastructure. So it is how it works.
Okay. Yeah, it's okay. So yeah, I think the time is almost up. So if anyone of the audience is interested to set up their infrastructure, feel free to reach out Isaac and their team offline. So really thanks for Isaac's support again. Okay, thank you. Thanks, Isaac.
Thank you very much.